All right, let's go back to ionic compounds and talk about the names and formulas of ionic compounds. The first simple step is that an ionic compound has a name consisting of the positive ion, yea, the cation, followed by the negative ion, the anion. So that's the order of the name parts in the name of the ionic compound. So the positive ion in sodium chloride is the sodium ion. Right? We talk about sodium ion and the chloride ion. So the name for this, if we wrote it out, would be first the name for sodium ion there, which is just sodium, as we'll see, followed by the name of Cl-, the anion, which, as we will see, has part of the name of the atom, which is chlorine, and an IDE ending so that we know it's an anion. IDE says it's an anion. Sodium, same name for the atom and the ion. Okay, now I'm going to talk about the simplest kind of ionic compounds first. Those are binary ionic compounds, and that means there's only two kinds of atoms in there. Sodium chloride would be an example of a binary ionic compound. So one type is the sodium ion, and the other type's the chloride ion. The metal cation name, as we saw with sodium chloride, is the same as that of the metal. So Ca is calcium. Ca2+ is also calcium. So when we name a salt of calcium, an ionic compound of calcium that has this ion in it, we just call it calcium. On the other hand, the anions named by taking the root of the nonmetal name, in this case bromine, bromine is the name of this atom. We take the root, which is brom, and we add IDE ending, and we get bromide. So the name for the ionic compound that contains calcium and bromine is, name the cation first, calcium, and then the anion, bromide. Okay, questions on that? Make sense to you? We just have to agree on how to make these names so that when you give me a name, I'll understand it. When I give you a name, you'll understand. So the compound formed from the metal calcium and the nonmetal bromine is calcium bromide. Now in table 2.3 there is a list of the common monatomic ions, cations and anions. This is part of the language of chemistry, and we ask that you learn as many of these as you can. Meaning, if I were you, I would get some small cards, 5x8 cards or something like that, or 3x5 cards, I guess, and I would put the formula for the ion on one side and the name on the other side. And that way you can study these things. So here are 4 things that we need to apply this information to. Name the binary ionic compound that forms from strontium and nitrogen. Okay, we saw a few moments ago that strontium is a metal. And so the metal is going to form which ion? Cation or anion? Cation. The metal forms the cation, the positive ion. So the name for the compound would start off with strontium. The nitrogen is a nonmetal, so we're going to take its stem name, which is NITR. We're going to add IDE ending to it. So this thing would be strontium nitride. IDE saying this thing is a negative ion. Now we could calculate's not the right word, we could determine the charges on these, and we'll do that later. For the time being, I just want to put the name on. Anybody have a problem with strontium nitride? Okay, what about sulfur and zinc? Zinc is a metal. Sulfur is a nonmetal. So the name for the ionic compound between zinc and sulfur will be zinc. And then here's our sulfur again. SULF is the stem. IDE means it's an ion, so negative ion. So zinc sulfide is the compound between zinc and sulfur. Not too bad, huh? What about aluminum and fluorine? Remember we talked about aluminum being the metal, right? Aluminum is a metal. Now fluorine is one of the halogens which occupy group 7A over on the right side of the periodic table, so it's a nonmetal. So we're going to take the stem name, fluor, and IDE to make its name. Aluminum fluoride would be the name of the ionic compound between aluminum and fluorine. What about oxygen? Metal or nonmetal? It's nonmetal, isn't it? So lithium is the metal, and so we're going to do lithium, and then ox is the stem, IDE makes oxide, lithium oxide. So that's how we assign the common names, well, not common, that's how we assign the names for binary ionic compounds. Does anyone have a question? Okay, you've probably seen that before and maybe you remember. Now the next thing I want to do is to learn to figure out the formula for these compounds. From the ions that are present and the knowledge that the formula must be neutral, we can figure out what the formula will actually be of these binary ionic compounds. So, the positive charges of the cations in a formula must be exactly balanced by the negative charges of the anions. So we have to take into account how much charge each cation has and how much charge each anion has to know the number of cations and the number of anions here. So, we'll go back to the compound calcium bromide. We know from the name it consists of calcium ions, Ca2+, in this case. I know it's Ca2+ because it's in group 2A and it needs to take 2 steps back to the nearest noble gas. We can check that out in the periodic table here. Calcium is right here. So the nearest noble gas is 18, calcium's 20, so 2 steps, that makes calcium 2+. Okay, the bromide ions come as single negatively charged anions. So there's going to be a requirement that we have exactly 2 bromide ions to go with 1 calcium ion, and we want to make the simplest possible formula we can, so the 2 bromide ions will go in with 1 calcium ion. So the formula would be CaBr2, and the overall charge, of course, would be 0. Sometimes you'll see this written in a way that shows the charges, calcium 2+ in parentheses, and then Br- in parentheses with the 2 following. We use the 2 to show how many of these ions are present there. Okay, and we use the parentheses here just to allow us to put in the charges so you can see why there's 2 bromide to 1 calcium. Okay. Now, you can use this method for any formula of an ionic compound for which you know the ions. Okay, and you know at least the main group ions to the extent that we saw them in the periodic table. So we can deduce other ionic formulas using the same method. So let me go and look at some more of these to show you. Write the empirical formulas for the compounds named in the previous problem. Empirical, sometimes the word is used for simplest formula, meaning the lowest possible ratio of these things. So what we're going to do to write empirical formulas is to write the simplest neutral formula. We're going to write down the ions and figure out the smallest number of each ion that gives that neutral formula. So if we go back to strontium nitride, we find that strontium is in group 2A, so it has 2 positive charges. And nitrogen is in group 5A, so it has 3 negative. You could check this in the periodic table. So what we need is enough strontium ions and enough nitride ions to balance the 2 charges. And you can see 1 to 1 won't do it. 2 strontiums won't do 1 nitrogen. 2 nitrogens won't do 2 strontiums. But when we get to 3 strontiums, we have 6 plus, and 2 nitrogens, we have 6 minus, and therefore the simplest empirical formula for strontium nitride is SR3 makes 6 positive charges, and N2 makes 6 negative charges. It's important that I get this clear to you. Does anyone have a question? Okay, so it's putting together things in such a way as to give the smallest number of ions that produce a neutral formula. Zinc iodide. Now, you don't know it yet, but zinc ions have 2 positive charges. Zinc's a metal. And you do know that iodine forms an anion with 1 negative charge. So it's pretty easy to see that 1 zinc is going to require 2 iodides. 1 zinc ion with 2 plus exactly balances the charge on 2 iodide ions. So the formula is going to be ZnI2. Okay, questions on that one? Good. Aluminum fluoride. Aluminum's in group 3A, and we saw a few minutes ago that its cation will be aluminum 3 plus. Takes 3 steps to get to the nearest noble gas. And fluoride is in 7A, so it'll have a single negative charge on its anion. So it's going to take 3 fluorides for each aluminum. 1 aluminum balances 3 fluorides, so the formula, the simplest formula, is AlF3. Questions on that one? All right, last one, lithium oxide. Lithium's in group 1A, so it will form an ion lithium with a single positive charge. Oxygen's in 6A, it will form an ion with 2 negative charges, so it's going to take 2 lithiums to balance that, and our formula will be Li2O for the simplest formula of this ionic compound. Okay, these things are easy to follow if you watch somebody else do them, but it's quite easy also to make a mistake when you're doing them yourself if you don't check the charges. You've got to be sure to check the charges. Any questions here? Okay, the main group elements are fairly easy to deal with because we have this rule, this tool that we have. Transition elements, B groups, often form more than 1 ion and with different charges, and there's no easy way to predict them. We represent the metal's ionic charge by using Roman numerals after the metal ion's name, since we don't know for a particular transition metal what the ion's charge will be. And let's take an example. Iron forms Fe2 plus and Fe3 plus. So in order to distinguish between these and not call them both iron chloride, we use these Roman numerals. And so FeCl2, since each chlorine is really a chloride and has a 1 negative charge, if there are 2 chlorides, the iron compound, the iron ion, has to be 2 positive ions, so we write it as iron Roman numeral 2 chloride, iron 2 chloride. The other one will be iron 3 chloride. Now, there is no simple way to predict these things, so we ask you to learn the ones that are in table 2.4. Again, you can do it with 3x5 cards. It's probably the easiest way. So I want to do some examples of this for you. so that you're comfortable with all these things. Here are four. Tin 2 bromide, tin Z is equal to 50. The 2 tells us that in this ionic compound, tin has what charge? +2, or 2 plus. So if that's the case, how many bromides will it take to form a neutral formula? It would be 2, won't it? So this, the formula for tin is SN for tin atom, and since it's tin 2 plus, then this will be tin SN Br2. Okay, the 2 just applies to the bromine here, and if I do it like I did before, it'll be SN2 plus and Br minus taken 2 times to show the charges. Okay, questions on that one? We're asked to give the formula from the name. Okay, the name is tin 2 bromide. The next one is CrF3, and we're asked to give the name from the formula. What would be the charge on the chromium ion in this ionic compound? It's 3 plus, right? So we would start this off by writing chromium. And what's the Roman numeral for 3? I. Okay? And the name for the ion, in this case, will be the fluoride ion. Chromium 3 fluoride is the name that applies to CrF3. Okay? Everybody all right? Iron 3 oxide says that we have Fe3 plus, and the oxide ion we already know is O2 minus. So in order to get a neutral formula, the quickest way to do it is to take 2 irons and 3 oxides to give 6 plus and 6 minus. So the formula would be Fe2O3. Fe2O3. Iron 3 oxide is the name for Fe2O3. Are we all right? Okay. MnS. Mn is manganese, and of course S is sulfur. It's a binary ionic compound. How do I know? A metal and a nonmetal. Now I'm going to work here, since manganese is a transition element, I don't know what charge its ion has. So I have to get sulfur to whisper it in my ear. Okay, sulfur ion, of course, is sulfide, S2 minus. So that would mean that we must have a balancing manganese charge. So that would be manganese 2 plus. The name for this thing would be manganese, not magnesium, manganese 2 sulfide. Do you have a question on any of those?